Hello, everybody. Today we want to talk about Black-Scholes option pricing in practice. Now, for this purpose, the stock that I've chosen, which is an ETF, is IWM Russell 2000. Now, we're going to start from the blank page on Excel, and we're going to start from downloading data, stock data, calculating the standard deviation, and then doing the option pricing. So the ticker for this Russell 2000 is IWM, and we need to download the data. So let's call this, for example, date, and then this is price. So I'm going to download the daily prices with using stock history. And I can, for stock, I can say IWM. And then start date can be today minus 365. So I want 1 year of data. And then end date can be just today. And then do I want daily? Yes. Do I want header? No. Do I want date? Let's say yes. Do I want what else? Close. So I'm going to just download all of this and boom. Here's the data for the past 12 months. So now that we got all the data for the past uh, 12 months, we can use this. First of all, let's calculate the uh, growth. Growth, it can be calculated as equals ln, which is natural log, the second number divided by first number. And I can just do this. And if I want to calculate daily standard deviation, I can just say equals stdev dot s, and then I can just choose all the numbers in growth, and that gives me standard deviation, daily standard deviation. Here we go. If I want to calculate the annual standard deviation, all I have to say is to say annual STD, and it's this number times SQRT square root of 252, which is the number of trading days in a year. So I got that one. Now, so I'm going to call this tab STD calculation, STD calc, and then go to another tab, Black-Scholes. So we can use this Black-Scholes for both put option and uh, call option. Let's do call first. So I'm going to start with required information that I need. Number one, stock price. Yes. So let me just here say it's S and stock price. Let's take a look at here. The very last day data that I have is 235.6. 235.6. So S is just stock price. Number two, K, which is strike price. Strike price. And I can, for example, here go to this and I can take a look at the strike prices. So, for example, here I can see that the, let's say, call option for, if I want to I mean, buy and sell, they are almost the same price. It's 534, 541. The spread is not that much. Let's say I want to do December 31st of 2025, and then I want to do strike price of 240. So strike is 240. What else do we need? T. Uh, so days to maturity is how many days? How many days do we have to maturity? 37 days. So let's say 37 days divided by 365. And so this is time to maturity or expiration in years. Okay. So I divided the number of days to maturity by 365. Then we have interest rates. Risk-free interest rate R is right now 0.041. So this is risk-free rate. And we need, let's say, Q, which is dividend. And we can just easily search that. But the IWM dividend yield is 1.02, as you can see in these websites. So I can go back to my Excel and say it's 0.0102. So this is dividend yield. Okay. And what else? So I got SKTRQ and STD, obviously. STD, I just calculated that. So it's this number. Let's copy that and then paste it here. I'm going to paste it as values. Okay. So that's STD, annual standard deviation. So later on, I know what's happening. Okay. So, and right now I want to do call. Okay. So here is the formula that we have for call and D1 and D2. The very first thing we have to calculate is D1, D2, ND1, ND2. Let's do that. So D1, D2, and then ND1, and then ND2. These are the very first things that we want to calculate. Okay, let's get started with D1 and D2. In order to make sure that I'm not making any mistakes, I'm going to just copy the formula here. I mean, I'm not sure if that's going to be that much helpful in Excel, but let's see if that works or not. Okay, it almost works. Make it smaller, and then I'm going to use it. So this is equal. How about I paste this maybe here so I have equals ln of s divided by k, and then the whole thing ln of this plus, now I want to say r minus r minus q plus zero point 0.5 times standard deviation squared. Then the whole thing times t. So the whole thing is the numerator. Yes. The numerator is this. And then the denominator, let me just add also the denominator is uh, denominator is sigma, which is STD, times SQRT of T. So that's D1. Good. We calculated D1. Let's calculate D2. The formula for D2 is given here. Let's copy and paste that here so we know what's going on. Okay, so it's D1 minus standard deviation times SQRT of T. Good, we calculated D1 and D2. Now let's calculate ND1 and ND2. If I want to calculate ND1 and ND2, I can easily do this. ND1 would be equals. So in Excel, you can use the function norm dot s dot dist, this function, and you just mention this and then cumulative, yes, true, and boom, it calculates it for you. One more time here, norm dot s dot dist, and then this, and then true. Boom, calculated that for me too. Awesome. Now all I have to do is to calculate this. So this is super easy and straightforward to calculate this for Black-Scholes model for call. Let me just have that maybe here. Make that smaller. Okay. And then let's do this. So here, call option. Okay. So it's equals S this times exp negative q times t, and then the whole thing times nd1. Perfect. Now minus k, so this is what we will receive. This is what we have to pay. K times exp negative r times t. and then times ND2. Perfect. I'm going to just use parentheses to make sure that these are easy to understood. I didn't make any mistake anywhere. Boom. And it gives me the call option price 5.277. Now the actual call, I can just go and check that actual call. So the actual call price for this is 240, 5.41, 5.41, 5.41. We can see that the numbers are super similar. So that's the call option. Now I'm going to copy this and use the same thing. So I'm going to copy the whole uh, tab, move or copy, Black Scholes, create a copy, okay. And I'm going to call this Black Scholes put. So how can we do this? So let's say put is the same 240. So far I got D1, D2, but here I want N negative D1 and N negative D2. So let me copy and paste the formula for put option. So D1 and D2, they have the same formula, but for the put option, we have this formula. So I'm gonna copy this and then paste it here. Okay, so ND1, all I have to do is to put negative this, correct? And then this one as well, negative this. Okay, now that I got those things, I can easily calculate the put option. So the formula is this, actual puts, and I can take a look at the actual put price. The puts actually for 240 is 9.53. 9.53. 9.53. Okay, let's calculate this. So the formula tells us what? Let's just calculate, copy this, paste them maybe here. Now the formula here, so D1, D2, and negative D1, negative D2, they're all calculated. All I need to do is this last option, last line of calculation, yes. So let's do that. Now I can say equals K. So here rather than B1, we have B2 times EXP negative RT. negative B4. How about I just do everything from beginning? Equals K, this guy, times EXP. Now I got the K EXP negative RT, negative R times T, N times N negative D2, this guy. Okay, minus S times EXP negative QT. So times negative D1, N of D1. So the whole thing here minus the whole thing here. Boom. And I got 8.92, which is a good approximation for something that costs 9.53. Uh, yeah, that's it for option pricing. And you can also compare these numbers to binomial option pricing. That's, for example, here's the binomial call. We saw binomial call was 5.82, and here we got the call option 5.277. And then the put option is as number of trees in number of binomial periods here goes up in binomial option pricing, the result would just converge to this Black-Scholes model. So that's call option, and this is the put option. We can compare that with binomial option pricing as well. 8.92. So here binomial is 9.3. So yeah, binomial is a little bit closer to actual prices, but this is the way that we calculate the Black-Scholes formula. So I did it for one call and then one put, and then that's it. This is how we exactly do it. Thank you very much for listening. Have a wonderful time.